current Xeon codenamed Irwindale. Intel's official launch of Intel 64, under the name M64T at that time, in mainstream desktop processors was the N0 stepping Prescott 2M. The first Intel mobile processor implementing Intel 64 is the Merom version of the Core 2 processor, which was released on the 27th of July 2006. None of Intel's earlier notebook CPUs, Core Duo, Pentium M, Celeron M Mobile Pentium 4, implement Intel 64. Implementations. Intel's processors implementing the Intel 64 architecture include the Pentium 4F series /5X1 series, 506, and 516, Celeron D models 3X1, 3X6, 355, 347, 352, 360, and 365 and all later Celerons, all models of Xeon since No Kona, all models of Pentium dual-core processors since Merom 2M, the Atom 230, 330 D410, D425, D510, D525, N450, N455, N470, N475, N550, N570, N2600 and N2800, all versions of Pentium D, Pentium Extreme Edition, Core 2, Core i9, Core i7, Core i5, and Core i3 processors. And Xeon Phi 7200 series processors. VIOS X86-64 implementation. VIA Technologies introduced their first implementation of the X86-64 architecture in 2008 after 5 years of development by its CPU division, Centaur Technology. 34. Codenamed Isaiah, the 64-bit architecture was unveiled on the 24th of January, 2008, 35, and launched on the 29th of May under the Violano brand name. 36. The processor supports a number of VIA-specific X86 extensions designed to boost efficiency in low-power appliances. It is expected that the Isaiah architecture will be twice as fast in integer performance and 4 times as fast in floating-point performance as the previous generation VIA Esther at an equivalent clock speed. Power consumption is also expected to be on par with the previous generation VIA CPUs, with thermal design power ranging from 5W to 25W. 37. Being a completely new design, the ISA architecture was built with support for features like the X86-64 instruction set and X86 virtualization, which were unavailable on its predecessors, the VIA C7 line, while retaining their encryption extensions. Microarchitecture levels. In 2020, through a collaboration between AMD, Intel, Red Hat, and SUSE, 3 microarchitecture levels on top of the X86-64 baseline were defined: X86-64 v2, X86-64 v3, and X86-64 v4. 38, 39. These levels define specific features that can be targeted by programmers to provide compile time optimizations. Features exposed by each level are as follows: /smiley 40. CPU microarchitecture levels. Level Pew features example instruction X86-64 baseline. All X86-64 CPUs. Move X8 CMPX CHG8 7 Kemsos Save Siscal Sec 2 ISSE 2 P2 PD X86-64 v2. Circa 2009, Nehalem and Jaguar, also Cemu emulation. Atom Silvermont, 2013. Violano and Eden C, 2015. CMPX-CHG16B CMPX-CHG16 Blaf Soft Laf Popkins 3 Add Sub SSE4 _1 Blend SSE4 _2 Compestry SSSE3 for X86-64 circa 2015. Haswell and Excavator, also Atom Gracemont, 2021. Afx roll of Xtuv Pound BMI1 and BMI2 GIF16 CVCVTPH tubes Med 13 Tools move BSX save X get X86-64 AVX512S general purpose subset AVX512 move AVX512 SITWOVX512 X512 MULCAVX512 VLN /. All levels include features found in the previous levels. Instruction set extensions not concerned with general-purpose computation, including AESNI and ADRAND, are excluded from the level requirements. Differences between AMD 64 and Intel 64. Although nearly identical, there are some differences between the two instruction sets in the semantics of a few seldom used machine instructions, or situations, which are mainly used for system programming. 41. Compilers generally produce executables, i.e. machine code, that avoid any differences, at least for ordinary application programs. This is therefore of interest mainly to developers of compilers, operating systems and similar, which must deal with individual and special system instructions. Recent implementations. Intel 64 SBSF and BSR instructions act differently than AMD 64S when the source is 0 and the operand size is 32 bits. The processor sets the 0 flag and leaves the upper 32 bits of the destination undefined. Note that Intel documents that the destination register has an undefined value in this case, but in practice in silicon implements the same behavior as AMD, destination unmodified. The separate claim about maybe not preserving bits in the upper 32 hasn't been verified, but has only been ruled out for Core 2 and Skylake, 42. Not all Intel microarchitectures like 64-bit Pentium 4 or low-power Atom. AMD 64 requires a different microcode update format and control MSRs, model-specific registers, while Intel 64 implements microcode update unchanged from their 32-bit only processors. Intel 64 lacks some MSRs that are considered architectural in AMD 64. These include SYSCFG, top_MEM, and top_MEM2. Intel 64 allows syscall /sysret only in 64-bit mode, not in compatibility mode, 43, and allows sysenter /sysexit in both modes. 44. AMD 64 lacks sysenter /sysexit in both submodes of long mode. 11. 33. In 64-bit mode, near branches with the 66H, operand size override. Prefix behave differently. Intel 64 ignores this prefix. The instruction has 32-bit sign extended offset, and instruction pointer is not truncated. AMD 64 uses 16-bit offset field in the instruction, and clears the top 48 bits of instruction pointer. AMD processors raise a floating point invalid exception when performing an FLD or FSTP OFAN 80-bit signaling LAN, while Intel processors do not. Intel 64 lacks the ability to save and restore a reduced, and thus faster, version of floating point state, involving the save and fxster instructions. AMD processors ever since Optron Reverend D and Athlon 64 Reverend D have reintroduced limited support for segmentation, via the long mode segment limit enable, LMSLE, bit, to ease a virtualization of 64-bit guests. 45, 46. When returning to a non-canonical address using sysret, AMD 64 processors execute the General Protection Fault Handler in Privilege Level 3, 47, while on Intel 64 processors it is executed in privilege level 0.48. Older implementations. Early AMD 64 processors, typically on socket 939 and 940, lacked the CMP-X-CHG16B instruction, which is an extension of the CMP-X-CHG8B instruction present on most post-80486 processors. Similar to CMP-X-CHG8B, CMP-X-CHG16B allows for atomic operations on octawords, 1 to 8-bit values. This is useful for parallel algorithms that use compare and swap on data larger than the size of a pointer, common in lock-free and wait-free algorithms. Without CMP-X-CHG16B, one must use workarounds, such as a critical section or alternative lock-free approaches. 49. Its absence also prevents 64-bit Windows prior to Windows 8.1 from having a user mode address space larger than 8 TB. 50. The 64-bit version of Windows 8.1 requires instruction. 51. Early AMD 64 and Intel 64 CPUs lacked LAF and SAF instructions in 64-bit mode. AMD introduced these instructions, also in 64-bit mode, with their Athlon 64, Optron and Turian 64 Revision D processors in March 2005, 52, 53, 54, while Intel introduced the instructions with the Pentium 4 G1 stepping in December 2005. The 64-bit version of Windows 8.1 requires this feature. 51. Early Intel CPUs with Intel 64 also lack the NX bit of the AMD 64 architecture. This feature is required by all versions of Windows 8.x. Early Intel 64 implementations, Prescott and Cedar Mill, only allowed access to 64 GB of physical memory, while original AMD 64 implementations allowed access to 1 TB of physical memory. Recent AMD 64 implementations provide 256 TB of physical address space, and AMD plans an expansion to 4 PB, while some Intel 64 implementations could address up to 64 TB. 55. Physical memory capacities of this size are appropriate for large-scale applications, such as large databases, and high-performance computing, centrally oriented applications and scientific computing. Adoption. An area chart showing the representation of different families of microprocessors in the top 500 supercomputer ranking list, from 1993 to 2019. 56. In supercomputers tracked by top 500. The appearance of 64-bit extensions for the X86 architecture enabled 64-bit X86 processors by AMD and Intel to replace most RISC processor architectures previously used in such systems, including PowerISC, Spark, Alpha and others, as well as 32-bit X86, even though Intel itself initially tried unsuccessfully to replace X86. With a new incompatible 64-bit architecture in the Titanium processor. As of 2020, a Fujitsu 64FX-based supercomputer called Fugaku is number 1. The first ARM-based supercomputer appeared on the list in 2018, 57, and, in recent years, non-CPU architecture coprocessors, PU, have also played a big role in performance. Intel's Xeon Finite Corner coprocessors, which implement a subset of X86-64 with some vector extensions, 58, are also used, along with X86-64 processors, in the TUM2 supercomputer. 59. Operating system compatibility and characteristics. The following operating systems and releases support the X86-64 architecture in long mode. BSD. Dragonfly BSD. Preliminary infrastructure work was started in February 2004 for a X86-64 port. 60. This development later stalled. Development started again during July 2007, 61. And continued during Google Summer of Code 2008 and SOC 2009. 62. 63. The first official release to contain X86-64 support was version 2.4.64. FreeBSD. FreeBSD first added X86-64 support under the name AM64 as an experimental architecture in 5.1 release in June 2003. It was included as a standard distribution architecture as of 5.2 release in January 2004. Since then, FreeBSD has designated it as a Tier 1 platform. The 6.0 release version cleaned up some quirks with running X86 executables under AM64, and most drivers work just as they do in the X86 architecture. Work is currently being done to integrate more fully the X86 application binary interface, ABI, in the same manner as the Linux 32-bit ABI compatibility currently works. NetBSD. X86-64 architecture support was first committed to the NetBSD source tree on the 19th of June, 2001. As of NetBS 2.0, released on the 9th of December, 2004, NetBSD /AM64 is a fully integrated and supported port. 32-bit code is still supported in 64-bit mode, with a NetBS 32 kernel compatibility layer for 32-bit syscalls. The NX bit is used to provide non-executable stack and heap with per-page granularity, segment granularity being used on 32-bit x86. OpenBSD. OpenBSD has supported AMD64 since OpenBSD 3.5, released on the 1st of May 2004. Complete in-tree implementation of AMD64 support was...
Yes, let's take a break. So, this is much nicer to read this kind of text. I better understand that than just long documents with codes. We have the evening news and the Danish TV, Danish broadcasting, Danish radio we have in 10 minutes. And the sun is, we have the sunset. And the weather changed a lot. It was very nice weather this Sunday. The first hours today, then we had really bad weather with rain and thunder. But I think I will try to finish this. We have, yes, we are about a half. So I think I will try to charge the camcorder when I'm watching the news on Danish television. And I think I have to download the new list of Intel processors. I have to download the new version. Then I will make a new list later. I think I will make a new list have a lot of socket there. Yes, I need to make a new list. And but we are out of time now, the video split, but I have some device, some paper. Paper. Let's get it out, we need it here. Yes, I was in the bookshop and buy paper. Let's get it out here. But I'll not do that right now, but I have to download the latest list of Intel processors. I think I will read again, I already read about 5 or 6 Intel CPUs, but I think I will do it again in the same order there, but I'll look at that later.